Hello everyone, welcome to class. In this lecture we're going to be describing scientific notation. We'll talk a little bit about what it is and then the method for converting numbers to scientific notation, and then we'll practice with a few numbers together. Okay, and for some of you this may just be a refresher, and but for many of you it may be the first time you're hearing this information. So what is scientific notation? Scientific notation is just a shorthand method for representing very large or very small numbers. Okay, so that's essentially the definition. And so let's talk about how we would represent a very large or a very small number. I've got two examples here at the bottom of the slide, and you can see the first number we have here, 1 million, is 1 times 10 to the 6th power, or the 6th exponent, when you convert it to scientific notation. Alright? Now, the way that you would do that is you would follow these steps. First of all, we know that every whole number has a decimal present whether we see the decimal or not. So it is there even if it is not written. So we know that in this number 1 million, there is, after this 6th zero, there's a decimal there. So the first step that we would do is we would move the decimal from this original number there after that 6th zero to the location in the number which will make it a number from 1 to 10. Or put differently, the number must be greater than or equal to 1 but less than 10. Okay? So in order to get this number greater than or equal to 1 but less than 10, if you look down here at the bottom, we'd have to shift the decimal 1, 2, 3, 4, 5, 6 places to the left. Alright? So next, we need to count the number of places that we moved it, and we've already done that. I did it as I moved the decimal. So this comma here after the 1, we're going to pretend is now a decimal. Alright, and we've moved the decimal over 6 places. The number of places that you move the exponent now becomes the power or index, or you might say exponent of 10, which is then multiplied by the new number. So here's our new number. We have 1 is our new number, and then 10 to the exponent or power or index of 6. Now, we have to consider the number line in order to determine whether that exponent should be a positive exponent or negative exponent. And the question we have to ask ourselves is, in order to return the decimal to its original position, which way would we need to move in light of the number line? And so I have a number line here with 0 in the middle, and when we move in a positive direction, we're moving to the right on the number line, and in order to move in a negative direction, we're moving to the left on the number line. And you have to remember, the question is not how do you get the new number or which direction do we go to get the new number, because remember, we had to move the decimal to the left 6 places. The question rather is, which direction on the number line would we have to go in order to return the decimal to its original position? And we have to move in a positive direction 6 spaces to the right in order to return the decimal to its original position. So then 1 million is 1 times 10 to the 6th power in scientific notation. Okay, so let's do it again, but let's look then at the example, or now let's look at the example of the smaller number. Okay, so we have this tiny fraction of a number. We have the decimal point, and 1, 2, 3, 4, 5 zeros, and then 657. Okay, so that's a very small number. So we're going to start out moving that decimal in order to convert our number to a number that is greater than or equal to 1 but less than 10. All right, and so we're going to move it until we find the number that meets that criteria. So we're going to take the decimal and move it over 1, 2, 3, 4, 5, 6 spaces to the right. So we'll end up with the number 6.57. That meets our criteria of being greater than or equal to 1 but less than 10. And now we're going to multiply it by 10 to the 6th power, but we have to determine whether that's a -6 or a +6. And remember, the question that we ask is, which way on the number line would we need to travel in order to return the decimal to its original position? And looking at the number line, since we would have to take the decimal place back to the left 6 spaces in order to convert it back to the original, then this is a negative exponent that is needed. So then this fraction or tiny number represented here in scientific notation is 6.57 times 10 to the -6th power. All right. Okay, so now that we've had a nice explanation on how to convert something to scientific notation, let's talk about a couple more things. So, powers of 10. A positive exponent usually indicates, well, it indicates that the number is greater than 10, or it started off being greater than 10. A negative exponent indicates that the number began as a number less than 1. Let's look back at our examples there and see if that rings true. We have a positive exponent in the first example, and look, the number definitely was greater than 10 to begin with. And in our second example, we had a negative exponent, and it was definitely a number less than 1 to begin with. Okay, the other thing that we need to note about the exponents is that if 0 is the exponent in the scientific notation, that indicates that the number was already between 1 and 10 when you converted it to scientific notation. For example, 3 represented in scientific notation would become the number 3, and then it's just multiplied by 10 to the 0 power, or 10 to an index of 0, or an exponent of 0. All right? And let's look now, let's not look at the metric system here, but let's look at this number here. So we have in front of us the number 4,540,000. And in order to convert this number to scientific notation, we know that in the beginning we have a decimal all the way over here to the far right after this 4th zero. Okay, and now we're going to move it until we meet our criteria of being greater than or equal to 1 but less than 10. All right, so 1 place, 2, 3, 4, 5. Can we stop here? No, because the number 45 is not meeting our criteria. So 6, we're moving it 6 places, and now we've met the criteria. We end up with 4.54, and then times 10 to the +6th power, because we would have to move it in a positive direction on the number line to return to the original number. Okay, so 4.54 times 10 to the 6th power is this number in scientific notation. Okay, now let's try that again with a smaller number. So here we have the decimal, or the tiny fraction of a number, of 804 10,000ths. Okay, so we have 804 10,000ths. So we need to meet our criteria of having a number that is greater than or equal to 1 but less than 10. All right, so the way that we're going to do that is we're going to move the decimal 2 places to the right. So we're going to move it over here after the 8. All right, and then that meets our criteria. We had to move the decimal 2 places, so we know that the numerical value of the exponent is going to be 2, but is it going to be negative or a positive 2? All right, so the way that we're going to make that determination, remember, is we have to determine which way would we have to move on the number line in order to return to the original number. And we would have to go in a negative direction with our decimal on the number line. Okay, so we would have to move to the left to go back to the original. So that means that the exponent is negative. So this number represented in scientific notation becomes 8.04 times 10 to the negative 2. Let's try one more, and then I think you'll have it. So here we just have the number 5. Now, remember, the whole point of scientific notation is to convert or be able to represent really large numbers in a simpler way, or really small numbers in a simpler way. But we can still represent numbers that do fall between 1 and 10 in scientific notation. The way we would do that is we're going to put the decimal where it belongs after the 5, and then we're going to multiply by 10 to the 0 power, because essentially we're saying it's 5 times 1 is this number, okay? So 5 times 10 to the 0 power, which is equal to 1, is the number 5 represented in scientific notation. I think that pretty much sums up everything, and we've had a little bit of practice with converting the numbers. You may see some scientific notation from time to time throughout this course, and so I just want to make sure that you're comfortable with it. If you have any questions about it, feel free to shoot me an email, or the better thing to do would be to post a question onto the discussion board that I've created in your eCampus course shell. You'll find a tab on the left-hand side in eCampus, and it's labeled discussion board, and then there's a forum in there called questions and answers. All right? Okay, we'll see you in the next lecture.